have seen modulus of f1 plus f2 equal to, when f1 and f2 are of equal magnitude, say f, that is equal to square root of f square plus 2f square into cos alpha, right? So we'll draw the diagram here. Two forces, okay, and we'll draw parallel to these forces. This is F1, one of the force, okay, this is F2, another force, this is F1 plus F2, okay. If these two forces are same, F, then the angle between them is alpha by 2 and alpha by 2. The total angle is alpha, therefore if both these forces are same, then it will be alpha by 2, right? This is A, B, C, D. Okay, you can call it as a parallelogram, right? So this is what we'll get. We'll go to the next diagram. Okay, therefore this will be equal to F1 plus F2. We'll write once again. Modulus of F1 plus F2, which is equal to F square plus 2f square cos alpha, right? And this will be equal to f square, f can be taken out, 1 plus 1 plus 2 cos alpha, right? F square we are taking it out. So this will be square root of f is f only. F square is f only, so not f. Square root of f square is f. 1 plus 1 is 2. So 2 also we can take out. Okay. And it will be 2 times 1 plus cos alpha. Right? That is a square root also. Right? Modulus of this f square we have taken it out. F square we have taken it out outside the square root, right? F square we have taken it out, so it becomes f. So 1 plus 1, 2. 2 also I have taken it out, 1 plus cos alpha. So you can use the formula, I hope you know the formula. So f into, what is 1 plus cos alpha? 1 plus cos, what is cos square alpha? That will be easy for you to understand. What is cos square alpha? Cos square alpha equal to 1 plus cos 2 alpha by 2, right? So this will be 2 cos square alpha is 1 plus cos alpha. Alpha means I am dividing angle by 2, so angle by 2. So this will be 2 cos square alpha by 2 is 1 plus cos alpha. So I will be writing here, already 2 is there, right? 2 into 2 cos square alpha by 2, right? Then square root of 4 is what? 2. So 2f square root of cos square alpha is cos alpha by 2. So 2 into 2 is 4, so I am taking it out. So only 2 cos square alpha by 2 will be cos alpha by 2. So if these two forces are, F1 and F2 are same, you will not get a parallelogram, you will get a rhombus. Okay, you will get a rhombus, and the resultant is equal to the incline to F1 and F2, angle is alpha by 2. That we have seen in the previous one, right? That we have seen in the previous diagrams, right? This one. This is a rhombus. Okay, not this. The last one, yes. Okay, and you are getting a rhombus. This is nothing but a rhombus, right? You are getting a rhombus here. Okay, we get a rhombus because F1 and F2 both, these two are both equal to F only, and the angle between them is alpha by 2, right? The last one, fine. So we got something like this. Now we go to corollary 2, then we go to next board. Okay. What is corollary 2? If F1 and F2 are perpendicular to each other, okay, then what will happen? Naturally, you will get a rectangle, right? Instead of parallelogram. F1, they are perpendicular, no, ij we can take F2 into j cap, and this is nothing but our F1 plus F2, right? This is because they are perpendicular to each other, we can take F1 I cap, this we can take F2 j cap, and this one is F1 plus resultant is F1 plus F2. Suppose we are taking the angle between them is theta, right? So what corollary 2 says that if F1 and F2 are perpendicular to each other, okay, then choosing I cap and j cap in their directions, because they are perpendicular, right? We can take I cap and j cap. So what we can take, what do you know about F1? F1 is nothing but magnitude into direction. What is F2? Its magnitude into direction. Therefore, what is F1 plus F2? Okay, that will be F1 into I cap plus F2 into j cap. So this will be modulus of F1 square plus F2 square plus 2 F1 F2, you'll write 2 F1 F2, cos of angle between them, cos of angle between them is 90 degrees, cos 90 is 0, so this will not come. Okay, simply F1 square plus F2 square will come because cos 90 is equal to 0, right? So you will get which is equal to 0. So you will not get this. Only F1 square plus F2 square alone will get. Okay, then similarly tan theta. Tan theta, previously what we saw, F1, F2 sin alpha, where we saw tan theta, this board. Let me see here. Okay, what is tan theta? Here, one more board. Here, tan theta is nothing but F2 sin alpha here. F2 sin alpha divided by F1 plus F2 cos alpha. Angle between them is 90 degrees. Sin 90 is 1. We know. So F2. Cos 90 is 0. So F2 by F1. Right? Okay. Tan theta equal to F2 by F1. Therefore, theta equal to tan inverse of, so we'll get theta equal to tan inverse of F2 by F1. That's it, right? Now we'll go to the next board, right? What is next one? Resolution of a force into its components. Okay. Given the forces F1 and F2, there are two forces F1 and F2. We have the resultant as F1 plus F2. We know this. Conversely, if F1 plus F2 is given, we want to find what is F1 and what is F2. This is known as resultant of the forces into its component. Okay, there can be infinite number of parallelograms with F1 plus F2 as the diagonal. Okay, we know only the diagonal. So infinite number of parallelograms have the same diagonal. So which one we are talking about? So that is what we are going to see. Bookwork. Okay, what is bookwork? To resolve a force F into components, okay, into components in two given directions. We want to resolve into two given directions. Okay, let same way we saw in velocity, right? E1 and E2 be the unit vectors. Same way what we have seen in the velocity. Let E1 and E2 be the unit vectors in the given direction. Direction is given, right? In the given directions. Let them make angles alpha, beta with our resultant. Okay? With F. Right? With this visible. Okay, now it is visible with F. Okay, it makes alpha and beta with F. Now, what is F? F may be expressed as how you can express as linear combination of. Okay, this is linear. Okay, linear combinations of E1 and another this one E2. These are the unit vectors. You know this already. F, how you can write? F equal to some constant times this E1 cap, okay, and some constant times E2 cap. Okay, what is this? Is all. That's what we will see in the next board. Okay, suppose you are having this F. The resultant F is given, right? We want to find the like F1 plus F2, similar to F1 plus F2, and we want to find the components. What else is given? Unit vector is given. Okay, this unit vector is given because n number of parallelograms can be drawn. So which parallelogram I am talking about? The parallelogram whose unit vector means component whose unit vector is E1. Another component I want whose unit vector is what? Whose unit vector is E2. So E1 cap and E2 cap both are given. Okay, in the direction E1 cap unit vector, in the E2 cap is given. And we want to find what is the component in the E1 direction, component of F in the E1 direction, and what is the component of F in the E2 direction. Suppose E1 makes an angle alpha, okay, with F, and this makes an angle beta with F. E2 makes an angle beta with F, right? And this F can be written, we know that. How you can write F? F can be written as, okay, some constant times, because some of these two forces, no, some force in this direction, E1 direction, and some force in the E2 direction, whose resultant is our capital F. Therefore, A can be written, this F can be written as A into E1 cap plus B into E2 cap. So this is very much similar to our previous diagram, right?